Hi, I'm Jimmy Chang, and we're here to talk about an algebra tutorial for the critical value method. Now, the critical value method comes in is it's used oftentimes in nonlinear inequalities. Now, what nonlinear, of course, is anything other than just x or anything that's involved in a fraction form. So it can be used in quadratic, cubic, or in this particular example I'm going to show you is I'm going to use a rational inequality for this. So for example, if you have x plus 4 over x minus 3 less than 0, here's how the critical value method works. What you want to do is you want to be sure that 0 is on the other side of any of the critical value method, that 0 is on the other side, and that no other number be on the other side. And if there is a different number there, you need to move it over and then combine the terms if necessary. Now, since 0 is on the other side, what you want to do is take every piece and set it equal to 0. Now, we're not saying these are the solutions, so these are going to be the critical values once we solve for them. So if you solve for x, you have x equals to -4. X is equal to 3. Now again, these are not solutions, these are going to be the critical values. So this is where the critical value method comes in. Now, what are we going to do with these? We're going to put these on the number line, -4 and 3. And because you know -4 and 3 are not going to be solutions because it's less than 0, strictly less than, -4 and 3 will not be included. That's where the open circles comes in. What we're going to do after that is we're going to plug in numbers around these into the original problem to see whether or not the numbers fit. So for example, we're going to pick a number that's less than -4, like -5, and plug it in. Now in -5 plus 4 is -1. -5 minus 3 is -8. Negative over negative is a positive. 1/8 is not less than 0, so numbers less than -5 do not work. Now, we're going to plug in a number between -4 and 3. Let's just say 0. 0 is always a convenient number if you can use it. Now, when you plug in 0, 0 plus 4 is 4. 0 minus 3 is -3. 4 over -3 is -4/3. -4/3 is less than 0, so that works. Now, when you plug in a number bigger than 3, like 4, do the same thing. 4 plus 4 is 8. I'm going to write it over here because I'm out of room. 4 plus 4 is 8. 4 minus 3 is going to be 1. 8 over 1 is 8. 8 is not less than 0, so unfortunately, numbers bigger than 3 do not work. Once you have your solution, you're going to go ahead and write your answer off in an interval notation. Since we know the numbers between -4 and 3 work, we're going to write -4 and 3 as an interval, but because the numbers themselves are not included, you use the parentheses notation. As you can tell, the critical value method is actually a pretty decent method. It might take you a little while to get there, but the process is actually pretty straightforward. Just set the parts equal to 0 to find your critical values, put them on a number line, and start using test numbers. So, I'm Jimmy Chang, and that's an algebra tutorial on the critical value method.